This is my name. This is my student ID.
How do we read it?
You can call me Marai. It's difficult. It's like Marai, Moli, Vendan. It's like difficult. Moli, Vendan. Marai, Moli, Vendan. 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 Vendan.
Marai, Moli, Vendan.
Yeah.
I mean, this M is also.
So that's no. That's initial.
So actually, it's just some M, some name. Right?
Yeah. So okay. So today I'm going to present a clip from a movie called Sunshine, which was released in 2007, directed by Daniel Boyle. So it's a story about a desperate mission to save humanity from dying sun. So
What is time machine?
what?
What is it?
Sunshine.
Yeah, time machine or spaceship or what? You said something.
Yeah, it's a story about a desperate mission to save humankind from a dying sun.
You said desperate mission?
Yeah, desperate mission. Yeah, so dying sun. So here's the plot summary. So in the mid 21st century, our sun is dying. Actually, in this movie, so a team of astronauts are sent abroad by a spaceship called Icarus II to reignite the sun's core and preventing it from dying. So whether they succeeded or not, it's what the story is about. So this is a clip from that movie. So let's play. Actually, this is a nuclear bomb. So as you can see, they succeeded in their mission.
Okay, so he succeeded.
Yeah, they succeeded.
Good.
So as far as we know that our sun is not going to be die in this 21st century. So our sun still have about 5 billion years to left to exhaust his fuel totally. So in this movie they said that the sun died because of the sun is dying because of premature collapse. So is it possible? So yeah, there are some events where a star can die due to premature collapse. So these are some of the possible triggers which triggers those events. So some strong stellar winds which may blow away the sun's surface matters. So this may cause premature collapse. In a binary star system, one of the star may steals its companion's mass. So likewise, it can trigger the premature collapse of another star. So if a supernova explosion happens near a star, let's say in a binary system, that shock waves may affect the star and may triggers that premature collapse. But in the case of our sun, there is no scientific evidence that it will go under premature collapse. So this one thing. And yeah, the main thing is can a nuclear bomb reignite the sun? So the obvious answer is no. So no matter what amount of nuclear bomb you use, we cannot reignite the sun. So let's see. Yeah, before I go into the calculation, so let's talk about Tsar Bomba. So this is the largest man-made nuclear weapon tested by Soviet Union on October 1961. So it has a power yield of about 50 megatons of TNT, which is 2000 times more powerful than bomb dropped on Nagasaki. So there you can see the comparison of some of the nuclear weapons. So here you can see how big the Tsar Bomba is. Here is one of a video about the explosion. Okay.
Экипаж одевает защитные очки. Приближается к точке взрыва. Высота 4000 метров. Осталось 3 секунды. 2, 1, 0. Взрыв сопровождался световой вспышкой необычной силы. В этот момент самолет-носитель находился в 46 последующих свечения, несмотря на сплошную облачность, были видны в радиусе до прямой столб, поднимающийся с земли, быстро увеличился в объеме.
So you can see the destructive power of the Tsar Bomba.
Диаметр пулевого столба составлял около 10 километров. Увеличиваясь в размерах, облако медленно поднималось вверх. В своем конечном развитии оно достигло высоты 60-65 километров.
So yeah, some of the primary and secondary stages used in that Tsar Bomba bomb. So as you can see, fission. The first stage is fission. So which triggers the fusion by producing a large amount of heat. So then the secondary stage is fusion. The same thing happens in sun, which releases energy. So they can increase the amount of power by adding another fusion, but they didn't do in that case. So okay, now let's go to the calculation. So this is the total energy output of the sun per second. So it's about 3.84 into 10 to the power 26 watts. So we can calculate this by using Stephen Boltzmann's law. So this is the formula. So by incorporating these parameters, we'll get that value 3.84 into 10 to the power 26 watts. So this means that the sun emits about 384 trillion terawatts of energy per second. So we all know that luminosity is nothing but energy emitted by a celestial object per second. So we can write that luminosity in terms of energy. So 3.8 into 10 to the power 26 joule. So that's the energy of the sun per second. So now here's the energy of that star Bamba. So this can be calculated using that Einstein's mass energy equation. So 2.1 into 10 to the power 17 joule is the energy of the star Bamba per second. So the number of bombs needed to reignite the sun for just 1 second. So this is the calculation. So we just want to divide sun's energy by Tsar Bomba. So after dividing, we'll get approximately 1.82 billion. So we need approximately 1.82 billions of nuclear bomb to reignite the sun for just 1 second. So imagine how you will reignite it with just like it's impossible, right, to reignite it.
So if you have 1.82 billion,
Yeah.
What is it? Bomb.
Yeah.
Can you reignite?
No. No.
So
I'll tell you.
what's the point of this calculation?
Yeah, it's just theoretical calculation, like approximately how much bombs we needed to reignite the sun, but it's not practically possible. It's just theory.
Okay.
So could this restart the sun? Actually, no. So compared to sun's fusion, that our nuclear weapon fusion is so negligible. So it cannot sustain that kind of fusion that sun uses. So, and you can see that sun have big size. So compared to those bombs, it's too big, right? Sun's surface. So the energy can dissipate in every direction too quickly. So they cannot be able to reignite the sun. So mass is also another parameter. So obviously we cannot reignite the sun. Yeah. So this is the conclusion, that even if we detonated 1.82 billions of tower bombs per second, we will be able to reignite the sun. So the sun operates on a fusion at a scale beyond the nuclear weapons what we are using now. So in that movie they reignited it. So that's not true actually. So this is it. So these are some of my answers. So today's English word, can anyone pronounce it?
I need example.
Yeah?
I need an example.
Example, just pronounce it by looking at it.
Syzygy.
No? Yeah.
Syzygy.
Yeah, Syzygy. Syzygy. So in astronomy, syzygy refers to a straight line alignment of three celestial objects like sun, moon, earth, which will occur during solar and lunar eclipse. So that's the meaning of syzygy, alignment of three celestial objects. So okay.
So could you show the previous page? Okay.
So that's it. Any questions?
Okay, good. Any questions, comments?
For me, it's just like at some point you're trying to search how much energy you need to put inside the sun to reignite. But isn't it like reignite? Isn't it also a problem like we're just lacking of hydrogen? Like I think the fusion in the sun is consume all the hydrogen. So if you put nuclear bombs, I think there's no hydrogen already fueled nuclear bombs. So I think also it's a question of amount of hydrogen.
It's too little, right? It's too little, right? Too little amount of hydrogen compared to sun.
Okay.
So it's almost negligible.
Yeah.
So
So, you have question?
I do have one question is it, what you calculate is that it will be impossible to sustain the power output of the sun by just nuclear bombs, right? I wonder if it's possible to calculate what would be needed if you want to restart, because the sun has its own material and mass. And I don't know if it would be possible to calculate the amount of energy required to restart a fusion chain reaction within that material. But I imagine it would be quite a complex calculation.
Yeah, I think we can calculate, but I'm not sure.
That's thoughts.
Well, I think due to gravity, so if there's enough material, it should ignite automatically.
Right. Oh, right.
There's already pressure.
Yes. So if we couldn't sustain it, then it wouldn't ignite spontaneously on its own.
Okay, it was very good. But so in 5 billion years, the sun is going to run out of fuel, right?
Yeah.
So can you, if you are alive at that time, can you consider what would you do to save people?
I think at that time
Can you,
the sun will be like red giant, right?
yeah, okay. Can you add that to your report? So
Yeah, okay.
first, what
Yeah,
happened to the sun in 5 billion years? What physics happens?
Yeah.
Then,
Okay.
if humans are alive at that time, what would you do?
Yeah. Okay.
Yeah.
Yeah.
It's a matter of discussion. There's no answer.
Yeah. Okay.
Yeah, but hope you can
Yeah,
create
okay.
an interesting discussion.
Yeah. Okay.
Okay.
Yeah.
Good.
Yeah,
Thank you for the report.
Yeah.
And you have a quiz?
Yeah.
Okay. Let's do that. Is there anyone online today? No?
Shall we start?
Yeah, why not?
That's all right.
Yep. We only have 5 seconds for each question.
Only 5 seconds. It's 10 seconds. Okay.
Everyone's so fast. Okay, good. Okay, congratulations, Leon. Good. You got everything correct, right?
I got the spaceship one right by luck. I was guessing between the two.
He already has 5 extra points. now it's 6.
Okay. Okay, thank you, Marai.
Thank you.
Good presentation. So maybe 5 minutes break for me to set up the computer.